Hi everyone, my name is Wiet van der Haar. I'm a solutions engineer at CrateDB, and today I want to talk to you about unleashing the power of multi-modal data. So let's dive into that. So basically time series everywhere, right? For example, your phone. Everything on your phone is more or less time series data. So if you look at the different industries where time series data is used a lot, is from manufacturing up until monitoring and security, right? So that data is used for forecasting, for analyzing trends, predictive maintenance, fleet management, forecasting, peaks, those kind of things, right? So time series data is used across the globe in all these different industries. And when you look at typical common data patterns for time series application, you want to have versatile data, right? You want to be able to contextualize that information. You want to use it for analytics and machine learning, and you want to create or enhance the end user experience. So if you look at the versatility of time series data, right, it's not only timestamp tags and values, as most people think time series data is. And to be fair, from the core or for the originally that was the case. But what you see more and more, you want to do more with that data, right? So you want to be able to enrich it and contextualize it. So you not only need the traditional tabular structure, but you also want to be able to use JSON documents. You want to be able to use full text. You want to be able to maybe do a vector. You want to do geospatial data, all from the same environment. And of course, you want to have dynamic schemas. So this is basically what we see across the globe, across the board. And this is what we, from a CrateDB perspective, try to help you with. So what I want to show you today is some basic stuff when it comes to creating and importing typical time series data, and show you some basic SQL query capabilities, and then showcase the multi-modal capabilities. And I think the power of CrateDB lies within that specific multi-modal capabilities, but I will show you, of course, during the demo. So let's switch over to our CrateDB environment. So this is the CrateDB cluster. This is just a single node box. It runs in Azure. And as you can see here, we don't have any tables created yet. So what we will do is let's start first by creating a table. So I will create a table called radar data. And like I said, I will start importing some data later. So as you can see here, so if we just have a quick glimpse on the create table statement. So we have a timestamp, we have a location, a temperature, a humidity, and a wind speed. And we have a column policy is dynamic. I will touch upon that a bit later because that's massively important for our schema flexibility. So let's ingest some rows here. So this is just a data set we have or made available through one of our repositories we have on GitHub. And as you can see, we actually imported 70,000 rows. So let's have a look at how that data looks. First, let's see what we have here. So we have actually created that table, right? You can see the structure, but also maybe good to touch upon that quickly. So CrateDB out of the box does sharding and does replication. In this particular case, we only have one node, so we don't have any replication, but we still have the sharding out of the box, right? So this is basically an empty table. Well, I loaded some data in just now, but out of the box, we will create, in this case, we created a table with 4 shards. As you start to expand, scale out your cluster, have more nodes, then of course those shards will be distributed evenly across the different nodes within the cluster. So let's go back here. So we imported the data. Let's select some rows. And as you can see, I'll just limit, just give me 10. But you see a typical time series data, right? So we have a location, we have temperature readings, we have humidity readings, and we have wind speed readings. So as you can see also, we have a couple of gaps. I will touch upon that later, but that's the typical thing you see within time series data. So let me show you what we can, for example, do by grouping the data. And of course, this is a pretty simple one, right? We just say, okay, give me the location and the average temperature for that location, right? So that's not really advanced stuff. But let me show you what we can do additionally that focuses more on time series, typical time series data. For example, we have the min by and the max by. So with min by, max by, we can do the get the timestamp where in this case the temperature was the lowest, right? So we get that timestamp, and also we can say, okay, give me the timestamp when the temperature was the highest. So we have the time of lowest and we have the time of highest. And then we can, of course, query the data, and you get the lowest temperature, and you get the time when that lowest temperature was recorded, and same, of course, for the highest temperature. So these kind of min by, max by situations are pretty useful for your time series data. But also, let's extend that a bit. Typical for time series data is that you have gaps when it comes to the readings, right? That can be due to a sensor malfunction or a disconnection somewhere down the line, but that's something you see often. What you want to be able to do is to basically fill in those blanks, interpolate the values, and that's what we can do with, for example, lead and lag. So with lag, you can basically, based upon the previous value, you could take that forward, and with lead, you could take the next value and take it backwards. So what you can do then is basically do that and select the previous temperature and the next temperature. So as you can see here, we have a gap. So we have a gap in the reading here, and you can see that we actually do have a previous temperature, and of course we have a next temperature. So using those values, you could interpolate the gaps and make sure that you have some sensible reading there. So if we use this same piece of code, right? So this is the same code as I just used, but now we're going to use it within a common table expression and use that previous temperature and next temperature to use that further down the line in a select where we say, okay, based upon the previous temperature plus the next temperature, we're going to divide it by 2, and we present that as interpolated temperature. So again, this is that row with a nil value, and now by using the previous value and the next value, we can calculate the average for that row and present that here. This is the interpolated value. So this is more or less, we can do way more, right? So this is just a small snippet of all the features we have using SQL, using our time series data, and what you can do from a CrateDB standpoint. So what I wanted to discuss and show you next is what CrateDB brings to the table when it comes to dynamic schemas, right? So if you think back of the table I created, I'm not sure if you're 100% sure that you know, but what I did is said, okay, with column policy is dynamic. With column policy dynamic means that you can start ingesting data in columns that are not even defined. So let me show you what we do there. So let me copy that. So show create table weather. And what I wanted to quickly show again, so we have timestamp, location, temperature, humidity, and wind speed. So let's assume you want to add data from a reading, which is called wind direction, right? So instead of only measuring the wind speed, you also want to measure the direction of the wind. So in this case, just for this demo, I just say, okay, I'm going to update the weather data. I just want to keep that same 70,000 rows within this table. So I'm doing an update here, and I set wind direction, which was not specified, as you can see here. And basically I fill that with a random value between 0 and 360. So submit that. That of course will take some time to actually fill that. And if we go back now to the create table statement, so now we all of a sudden have a column called wind direction, which is of type begin. So you can see very flexible to add a column. And the great thing here is that we index everything out of the box. So you don't have to worry about indexing this additional column that you added by ingesting data. So that means that from the get-go, you can start using that wind direction to actually do some, well, in this case, we're going to calculate the average wind direction for that particular location, where the wind direction was between 90, which is east, and 180, which is south, and then group it by location. So let's query that. And basically you end up with, again, those cities with the average wind direction. So you can see that the flexibility of the dynamic schema within CrateDB is massive. So what I also wanted to talk to you about is what we can do from a JSON perspective, right? So CrateDB supports JSON, and I will show you what we do. So again, I will use that same table, right? I'm not going to create something else. I'm just going to use the same weather data. I'm going to add a column called location details. It's a type object. This is our data type for storing JSON. And I say I want to have it dynamic. Dynamic means that every JSON element you add to that is indexed out of the box. We also have strict, right? So if you want to confirm yourself to a particular a set of JSON elements, and you want to define that, you can do that also, and you can use it strict. But also we have the option to ignore, which is basically dynamic, but without the automatic indexing functionality. But let's add this column. So when we look here to the admin UI, we see that we have the location details, right, which I just created, which is a type object. We don't have anything there yet. So let's see what happens when we start to insert data into that added column, right? So again, I will run an update on the weather data, and I will set the location details, and I will basically do a query. I say, okay, where location in these cities we have within that time series data set, and we're going to update, and we're going to insert a name, and we're going to insert a country. So let's run that. And so that's done. So when we go back to the tables overview here now, so we have that location details, right? That's what we already created. And now you see that we have two JSON elements called name and country. Both are text based upon the data we ingested, right? Again, this is dynamic. So you don't have to define anything there. And again, this is indexed out of the box, so you can start querying using that a column and those JSON elements. So as you can see here, this is the notation if you want to query your JSON object within CrateDB. You can specify it like this. So between the between brackets and between single quotes. And you can basically use that to select your data. And as you can see here, we get all the unique location details, but I'm ordering it here by name. And as you can see, that's actually happening. So that's good. You could also use that same JSON to also query it further, right? So in this particular case, this is more or less the same query I had previously, right? With the average wind direction. And now I'm basically saying, okay, I only want to see the average wind direction for where the country is Germany, and still between east and south, I want to have that. So submit that query. And as you can see, you basically get that value back. So you can see the flexibility of not only ingesting data, but also querying data. But we can take it a step further where we can also do some joins, right? So in this case, I will do an inner join on the weather data location, right? That's that column that we had initially. But also I will match that to the location details name, and we're basically going to select and the location, the average temperature, and the country based upon those different columns, right? So as you can see, we can easily do an inner join, and of course you can do that across multiple tables. You can join that, right? So that this shows you how flexible and also how powerful this object within CrateDB is. So let's take it a bit further, right? So I also talked about geospatial and the use of geospatial there. So what I'm going to do is show you how we could add a geo point. So again, this is that particular column, right? So that location details, we already had that, but we're going to add a JSON element called position, and that JSON element is a geo point. So I'm going to execute that. So if you look now back to the table, you can see that we now have a position which is of type geo point. And then you can do you can do an update to actually ingest those positions into that JSON document for the JSON element position. So let's run that. Again, this looks like the previous command where we ingested name and country, but here we're going to add it with position. So when we look at that, we can actually query that. And the great thing is that because it's a geo point, of course, CrateDB understands that. So for example, we have the average temperature, but now we can also click here and open Street View and basically see where that point is. So this is Berlin. And of course, for the other locations, it's the same, right? So this is the power, and you, again, can use that to combine, join data, enrich your data with these additional data types we have within CrateDB. So what I wanted to do as a last part of this exercise is show you what we can do from a full text perspective. In this case, I will create a different table. The reason for that is that I'm using some chunks of text for the description of the different locations, and I didn't want to update all the 70,000 rows within every row more or less the same information. So what I create is a table called city details, and then I'm gonna insert some data there. This is a bunch of text. So let's submit the query. So let's have a look on how that looks from a SQL perspective. So I'm going to query it. So you can see we have for every city, we have a small description of that particular city. But then we can do some fuzzy searching. So for example, if you want to search, I'm going to search for the word large. And the fuzziness is basically says, in this case, that 2 characters may differ from the word large, where I'm searching for in the description in that particular city details table. So as you can see, you also get a score, and of course you could use that score to get the one that's closest to that particular search phrase you're searching for. So we can take that a bit further again. So you can do some joins, right? So what I will do here is join those city details with the weather data, and I'm gonna basically search using that large, and based upon that, I'm gonna take that to actually give you some information of that particular location. So we have Berlin, we have Zurich and Dortmund. So we combine the highest temperature, we combine the time of the highest temperature, right? So that's what we get from the weather data. And then we get the description based upon the join between the city name in the weather data, and of course the name of the city details, and that way join. So this concludes my my demo. I hope it gave you a better understanding of what CrateDB can do from a multi-modal perspective, but also from a SQL query capabilities, and how it can help you with your time series data. Very quickly to resume, CrateDB solves this, right? So CrateDB is a distributed multi-modal SQL database. So we can handle traditional table structures, we can handle JSON, we can handle time series data, geospatial, blobs, full text, and even vectors. We do everything out of the box when it comes to indexing. We do everything out of the box when it comes to sharding and replication. We can run on the edge, we can run on-prem, we can run in every private or public cloud. We have dynamic schemas. You can define your real-time user-defined function, and that is all queryable through native SQL, which makes it very easy to integrate, to onboard, to use it on the consumer side, but also from the ingest side. So I want to thank you for your time. I hope it was giving you a lot of information. I hope to see you at the stand. Bye.